Hey guys, so today we're doing our very last lesson of this chapter, which is also the last lesson of this unit. So we're just still going to be using the same tan, sine, and cosine ratios as before. The only difference with this lesson is that we're going to be dealing with multiple triangles at once. That means that when you're looking for a side or angle, you might need to solve for a different side or angle first in a different triangle, and then slowly work your way towards whatever it is that you're actually trying to solve for. So let's get into a couple examples. Okay, so in this first example here, we have this shape, these triangles. Now, it is important to remember when we're dealing with these simple trig ratios that you can only deal with right triangles. So this triangle right here, which is not a right triangle, is by itself completely useless to us. The two triangles that we're dealing with here are this small right triangle and then this larger right triangle. Okay? So it's asking us to solve for this x. So really what it wants is just part of this entire side here. So all that we need to do is figure out what is the length of this entire side, what is the length of the side of the smaller triangle, and then just take the entire side of the big triangle, subtract the side of the smaller triangle, and whatever's left over is that x value that we're looking for. So let's get into it. I'm going to start with this smaller triangle here. I've got this angle of 20 degrees. Across from it, this is the opposite side. This would be the hypotenuse out there, which makes this my adjacent side on the bottom. Now, because I have the adjacent side and I'm trying to find the opposite, according to my SOHCAHTOA, I need to be using tan for this. So my first step is going to be the tan of the angle, which in this case is 20. So the tan of 20 is the opposite side, which is what I'm looking for. In order to not confuse it with the top part, I'm going to call it y, over the adjacent side, which is 42. And then anytime I have a fraction, of course, I need to move whatever's on the bottom. So I'm going to multiply by 42. That cancels out. What I do to one side, I also need to do to the other. That leaves just y on the right-hand side. And then on the other side, I'm going to do the tan of 20 times 42. And that gives me 15.29-ish. Okay, my second step is now going to be to use this entire angle of 55 degrees, the adjacent side of 42, and this entire opposite side over here. The entire opposite side, I'm going to call W. Again, because my angle is kind of in the same spot, W is the opposite side, 42 is still adjacent. So I'm still going to be using tan, but this time it is the tan of 55 is equal to W, my opposite side, over the adjacent side of 42. And once again, multiply by 42 on both sides. So the tan of 55 times 42 is 60. So this entire side of this large triangle here is 60. And so my last step to find x is to just take the entire side of 60, subtract the lower portion, which is the side of my smaller triangle, so subtract 15.29. and we get 44.7 centimeters as our X value, which I realize doesn't look accurate at all, but that's just because these angles probably aren't drawn very accurately. Okay, so keep that in mind when you're drawing your diagrams and stuff like that. They don't have to be proportionate, as long as you can figure out where the right angle is and then where your opposite hypotenuse and adjacent sides are. That's all that really matters. Okay, let's walk through one more example. So for this example here, we once again have two right triangles. The first right triangle is right here. And then the second right triangle is right here. Okay, so it wants us to find the measure of this angle here. But if we look at just this triangle, we have one side and that's it. We don't have any of the angles in that triangle, other than our right angle, and we only have one side. There's nothing we can do with that. So we're gonna have to figure out one of these other two sides before we can actually start to solve this angle here. Now, because this side, this line right here, is shared with my other triangle, it's the hypotenuse of my other triangle, if I can use this triangle to find this side right here, then I can move on to solving my second triangle. So that's what we're going to be starting off with. So I'm going to start with this first triangle here with my angle of 23 degrees. Across from that, we have the opposite side. Across from my right angle is its hypotenuse, which makes this the adjacent side. So step one, I'm going to use the angle that I'm given, the 23 degrees, my adjacent side, and I'm going to try and find the hypotenuse. And again, the reason I want to find the hypotenuse and not the opposite side is because the hypotenuse is a shared side with the other triangle that I'm trying to get to. So step one, the ratio that uses the adjacent side and the hypotenuse is my cosine ratio. So the cosine of 23 is the adjacent side over the hypotenuse, which I'm just going to call h for now. So of course, because the h is on the bottom, I need to multiply by h, which cancels it out, and then do the same to the other side. That leaves me with the cosine of 23 times h equals 9. And so, of course, in order to isolate the h, I need to divide by the cosine of 23. So 9 divided by the cosine of 23 gives me 9.78 approximately. Okay, so this side is now 9.78. Now I can move on to my second triangle. And for this, once again, I need to start by labeling my sides. So across from the right angle is my hypotenuse. Across from the angle that I'm dealing with is the opposite side. So even though this 9.78 was a hypotenuse for my first triangle, it is no longer a hypotenuse for my second triangle. It is the opposite for my second triangle, which would make that side down there adjacent. Now, in order to find this angle, I need to use the opposite side and the hypotenuse, which means I'm going to be using my sine ratio. So the sine of my angle is the opposite, which is 9.78, over the hypotenuse, which is 41. In order to get rid of my sine and isolate my angle, I'm going to take the inverse. So my angle is going to be equal to the sine inverse of 9.78 over 41. So second sine for my sine inverse, and then 9.78 divided by 41. And I get that my angle is 13.8 degrees. Okay. Again, don't worry that it doesn't look like that. This angle is probably not 23 degrees. It's probably closer to 45 degrees. That's why nothing looks proportionate, but that's fine as long as we have our sides and everything labeled properly. Okay, so that's it. It's just kind of like a puzzle that you have to kind of like work backwards through to get to whatever angle or side it is that you need to eventually find. But yeah, let me know if you have any problem with these questions.